Um, so we're going to talk about SQL, which stands for Structured Query Language. It is the basic languages of almost all databases today. A very popular free database that's now owned by Oracle and very popular, especially among startups, called MySQL is the one we'll look at. And tonight and in a couple of weeks, we'll look at how it can be used with Java or PHP. So we'll just kind of briefly talk about structured query language, how to use SQL, retrieve data, manipulate. Install MySQL and configure it. I'm not really going to go into that because it's not necessary. I'm just going to go into some database basics. It's very easy. The best thing to do is just to download XAMPP because it's got everything you need. It's got Tomcat, which runs the Java stuff. It's got PHP and Apache built in. It's got MySQL built in. So look for XAMPP if you want to do some of this stuff. So we won't actually look into those last couple of parts. We'll talk about a relational database, and we'll look at some of the basic ways of getting data out of a database. This is called query. And a database is basically a place where you store large amounts of data, and it allows you to manipulate the data pretty easily. You can think of a database table as being like a worksheet in Excel. And the rows and worksheets have rows and columns, and you can store data in a very tabular format. And that's what a table in a database is. The main exception is that a database table is capable of storing and quickly retrieving very large amounts of data. An Excel spreadsheet, has anyone ever opened an Excel spreadsheet with like more than 10,000 rows of data in it? How long does it take to open HAL if it's a really large table? Take a few minutes. It takes a long time, right? Well, that's only maybe 10,000. Well, for a database, 10,000 is chump change. It really is chump change. Databases can deal with millions of rows, so it's really chump change. So, a database is kind of like an Excel spreadsheet on steroids. And, kind of like, what's his name? I shouldn't say it. Get his name. Strong Armstrong. Databases are a little like if Excel is a regular bicyclist, then databases are Armstrong. They're like databases. They're like Excel files on steroids. They can deal with very large amounts of data. So we'll look at the select statement, which is what gets data out. And then we'll also look at being able to get data from multiple tables. Also, how to insert, update, and delete data with those commands in the database. Again, we're going to go through MySQL. We're not going to go through installation instructions, creating an account, creating a database in MySQL. That's all going to be pretty much done for you. The So again, here's an example of a table. We would say that this is a row of data, and this is a column. So it looks, again, like very much like a spreadsheet in Excel. And here's another one. And I believe I have those two. Now, I created a link to these, and I did. All right, so if I were to go ahead and say view this data, and I'm viewing it in NetBeans. Okay, it executed. Where's the data? Finish. One column. Okay, where's the data? Okay, it looks like there's no data in there is the problem. If I'm reading this right. Oh, well, hold on for a second. Ah, there we go. There is data in there. There it is. Okay. So that's a very simple statement for getting data out called a select statement. But the author, first name and last name, that would be under the authors table. And if I go and say view this data, again, it'll do it and shows us that data. Not much in there right now, but that's just sample data. So if we look at the data we see in the authors, we've got 3 columns. The author ID is what we would call the unique identifier, in database terms it's called a primary key. The next table we're going to look at is called the author's ISBN table from the next database. So this kind of brings about something called relationships in databases. Databases, why it's called a relational database is because databases have the ability to relate to other tables in many different ways. And the 3 typical type of relationships are called a one-to-one, which means one table will match to data in another table on a one-to-one basis. One-to-many, which means a row in a database can match rows in another database table many times, multiple rows in another table. And the third type is called a many-to-many relationship, which basically means that table A can have multiple matches to table B, and table B can also have multiple matches to table A. So think about books. We have authors, books, and authors and books. Well, books could have more than one author. So we've got, from books to author, we've got a one-to-many relationship. Well, the problem is authors also have a one-to-many relationship because an author can write multiple books. So that's a one-to-many relationship. The way we normally handle a relationship, a one-to-many relationship, is the primary key of the one row of the table with the one part of the relationship is placed into the table that has the many part as a column, and we generally refer to that as a foreign key. The problem with a many-to-many relationship is you can't do that because you can't directly put each other's primary keys in the same table because you're automatically creating just a one-to-many relationship. And we've got to create a many-to-many relationship. And this is a lot to go over real quick because this is a full semester course. But the way it works is that you create a third table. You resolve a many-to-many relationship, which is not directly possible, with a third table, often called a bridge table, that has a one-to-many relationship of both. So this table, author's ISBN, has a relationship, a one-to-many relationship with authors, and it also has a one-to-many relationship with ISBN or book. And by having those two one-to-many relationships, we essentially create a many-to-many relationship between authors and books, which is how it works in the natural real world. The books themselves are got ISBN, title, edition, and copyright. And I think if we look at here, SQL Command 1, I already took the books out. And you can see that we have the ID, the title, and the ISBN. And the category, which we've got the number. Now, if we look at author's ISBN, and we see we've got an author ID and an ISBN ID. So if I wanted to know what book author 1 wrote, then I could go into books and look up for 1, and I know it's the introduction to the web. But that can get kind of time consuming. So generally what they do is they create a join. Okay, so a couple things about primary keys is that you have to have one. You can't not have it. It's required. And second, they can't be duplicate. You can't have multiple rows of the same primary key. A primary key is like your social security number or something. It's unique to that row of data. So again, here's our train, and we see authors has what we call a 1, and that's sideways 8 means many, to relationship with author ISBN. And then titles also has a 1-to-many relationship with author's ISBN. That creates a de facto many-to-many relationship between authors and titles. That's a lot, obviously. Generally, we spend a lot more time than this on database stuff. Okay. You have to provide a foreign key, and it has to match a primary key in the table you're relating to. If it doesn't, you're breaking another rule of databases called referential integrity, which means you can't make a reference to something that doesn't exist. Okay, so now we're going to look at the SQL select command. And there's a bunch of different variations on it. We've seen the very basic SQL command, select star from books, means select every row and column from the table books. That's the simplest type of select command you can have. From is the table. Where is a filter that you can put on the rows, so you can limit the number of rows based on a Boolean type expression similar to a while loop or an if statement. Group by creates groups of data. Group something, sales by state or something. A little more on that later. Order allows you to order it. So if you want to order it by the last name, first name, or both last name and first name, you can do that. Now, inner join, we're going to talk about it in a moment, is it creates a relationship between two tables, and we'll get to that later. Then also there's something called an insert, update, and delete command that allows you to change the data in your table. For most queries, the asterisk should be used to specify column names. Should not be used. It's a wildcard. It includes everything. You should really select only what you actually want. Excuse me. So, for example, in here, I shouldn't say select star. I should probably say something like select title. Then I get just that. Just that information. You should actually give the column names, and that's because you don't want to take more data out than you need. It's inefficient disk I/O, so you should really just take what you need. If you assume that the columns are always returned in the same order, the query use the asterisk, the program may process results incorrectly. So you shouldn't use these wildcards, really. It's okay for ad hoc stuff, but not inside your programs. It's inefficient. Okay, so we can select just the author ID and last name. And if I wanted to do that in my query, I can go, I think, to this way here, do that, and I can say select from authors. And I get now just the author ID and the last name. I don't get the first name any longer. Separated by a comma. This is another one, the titles. Copyrights after 2005. That would be what we would call a where clause. And let's just go back to the asterisk for a moment. So if I want copyright, I don't seem to have a copyright on this one. On this table. That's interesting. Okay, well, we would do a where clause, but I could say where category is equal to, let's say, 5. That will only bring me back to rows out of a category 5. So there's your filter. The where clause creates a filter. Last name starts with D in the authors table. That is something known as a wildcard. So if we go to the authors table, I can say where last name is like D%. Okay, so and I'll explain this in a moment. Ditel. So the like command is sort of like a wildcard, a pattern matcher, that says instead of looking for an exact match, you're looking for something that matches some pattern. And our pattern is pretty straightforward. The letter D means that it's got to start with the letter D, and the percent sign means it could have any number of characters after that. So this gives you all of your authors whose last name starts with the letter D, which is these two, Ditel. Contains an O. Okay. Well, you can do that as well. Now you want something where it contains an O. So now what we have to do, before it had to start with a D, so we had D and a percent sign, but now we want only if it contains an O. So the way we do that is we say that it's got to be like, it can start with any number of characters, it's got to have an O in there somewhere, and then it can end with any number of characters. And then that gives us essentially all names that contain the letter O. Sending order by last name. So I'll get rid of this. And the sending order by last name is just order by last name. And you can see it's by last name. It says ascending. Ascending is the default sort order. You can also do descending order by adding on the word descending. Or really just the 4-letter words DEF. Now that will start with the highest and go to the lowest. And then here it's in descending order now. You can sort by more than 2 columns. You can do it last name and first name. I can say comma first name. Of course, we want to say first name here. So now it's going to sort it by last name and then by first name. So if we look at Ditel, we got Harvey, then Paul. Titles that end with how to program. Where title is like percent how to program. So percent means it starts with any number of characters, but then it's got to end with how to program. There's no percent at the end. So it's an example of how to do another query. A SQL statement includes columns with the same name from multiple tables. The statement must precede those column names with their table names and a dot. We haven't seen that yet because we have to do a join. And we'll see a join in a moment. Failure to do that will cause an error. Okay, so now we want to get a list of all authors and the books they've written, the ISBNs they've written. Well, that data is not in one table. It's in two different tables. It's in the ISBN table, or the books table, the author's ISBN table, and it's also in the author's table. So if I want to get that, how do I do that? I know if I look at that the ISBNs will be in the author ISBN table, and we can find it by the author ID. So this is how you can do it. Authors join on authors, and you can actually just say on using and now at this point I've got to put in authors okay, didn't like something tough. Since the table doesn't exist, I think it's author ISBN without the S. Okay. And we also want to take obviously the ISBN, because that's what information we're looking for. So we basically, what we did is we said, take data from authors, take the ID, the last name and the first name from authors, and then also join to the author ISBN table based on the author ID. They have a column in common, the author ID. And then ISBN will come from the author ISBN table, and we're still ordering it by last name and first name. So that's a join, when you join two tables together. Always explicitly list the column when inserting rows. Okay, so we're looking at an insert statement. The tables column changes order. You got to be careful with quotes, because the problem with quotes are that they're a special character. That's how you delimit strings in databases. But if you have names that contain a quote, it's got to be escaped. And it's not escaped the same way you do it in JavaScript. In databases, it's escaped by essentially doing the same character twice. So, if I wanted to look at this and say, I don't know that we have this, but let's just take all the authors. We have O'Malley. Now, if I try to say where last name is equal to O'Malley, it's going to be an error, because this single quote here ended the string. So the way you get around it is you just do it twice. Now we're going to get it. Okay, so let's look at how we insert data. It's fairly straightforward. I can say let's use this one here. Insert into authors, last name, first name, values, kind of any values I want. we look at this, nothing there, no one by the name of Smith, right? No one there. Okay, good. Go over here and I execute this, and it says it completed. Now if I go over and I rerun this query, look, new author in there, James Smith. I didn't give it the author ID. It created it itself automatically. It does that because I set it up as a primary key, and databases generally will generate the primary key themselves. Essentially creates them in order, sequential order, which is how you want them to be created. Now the next is, how do we do an update on these guys? Well, let's say I want to change my first name to my legal first name, which is Robert, not Bob. So I can go in here and do an insert, or an update rather, excuse me. Now I have to get the author ID, which for me is 6. So the way it works is we simply say update authors, the authors table, set first name equal to Robert, where author ID equals 6. So it's going to go in there, it's going to look for the row with an author ID of 6, and it's going to change the first name to Robert. So that when I go back here and I run this again, it didn't work. What happened? Table test authors doesn't exist. Oh, there's an E in there that shouldn't be in there. Okay, let's try it now. Now my name changed to Robert. You can also delete data from tables pretty easily. Okay, so we'll delete one. I'll delete that O'Malley guy since it's kind of a pain to deal with his last name. And we can delete by name too. So I can just say delete from authors where last name is equal to and if I go over here, we should see one less author. And he's gone. Okay. That's kind of like a quickie introduction to databases. Questions? Any questions on that? Here are some SQL examples if you want to try this stuff at home. There's an example there where you can try different things. Different commands. It's got commands for creating a table. This will create a table. Some examples to do insert statements. A couple of variations on how to do insert statements. Select, a couple of variations on different types of select statements. Any questions on any of this? So these are your basic commands. You've got the create table command, which you should learn. We haven't done it yet, but you have to create table. I don't know that we've got any of these tables here that I can... You can probably create a table here, or you can do it programmatically. We've pretty much got all these tables, but let's just try. This one works. Let me see. Why? May not have this one. It already exists. The MRS I got with it already exists. But if it didn't exist, it would have created that table. I mean, I could say, 2. And it created it. Now, right now, we see that there's a contact info. And in order to, there it goes. Now it just brought up contact info too. So it created that database. Deleting tables is pretty easy. You just type drop table. And that deletes the table. Okay. Any questions on any of this database stuff?